Hi, everyone. So, in today's lecture, we are going to be looking at what environmental science is. And this is going to be pretty brief and is going to be a pretty broad general overview. When we're talking about environmental science, what we are talking about is the systematic study of our environment and our proper place in it. So, when we talk about the environment, oftentimes we are talking about the natural environment, right? Which means the air, water, and land in or on which organisms live. But we can also take a broader definition of the environment and include the social and cultural circumstances that surround that organism, right? And that's particularly true for humans. So it's not only, the land and air and water that is around us, but it's also our social environment and our cultural context that kind of includes or wraps up this idea of environment. Now, when we are dealing with environmental science, right, this is really a multidisciplinary field, right? And if you look at the figure on the right there, you could see how all of these different um, disciplines all play a role in what would be a goal in environmental science. And that example would be a goal would be a clean energy future, right? And you can see how these disciplines such as ecology and chemistry and political science, sociology, urban planning all have a role in trying to achieve this goal of a clean energy future, right? Chemistry talks about how we can make better batteries that store energy better. Ecology would be how these energy production affects populations of organisms. Economics, what are the benefits and costs of different energy sources? Political science, what policies lead to these sustainable solutions or clean energy, right? What policies or what aspects of clean energy make that politically attractive, right? So, and that probably sociology would deal with that as well, right? So all of these things, all of these different disciplines, all play a role in this field of environmental science, right? And what we're doing is not only identifying remedies for environmental issues, which we'll look at in a little bit, but we're also identifying how to make those remedies socially and economically and politically acceptable, right? That's kind of what I just mentioned there. It's not just focusing on the natural environment and how we conserve the natural environment or clean it up or protect it, but it's how we make those remedies that we figure out, how we make those remedies socially or economically or politically viable. Now, within environmental science, what are some of these topics that we're dealing with or these remedies that we're trying to address? Well, it's really anything that relates to us in the environment, right? Or sometimes just the environment, right? And our role or how we affect it. So, for example, environmental science will deal with population growth and resource consumption, right? We live in a world where population is still expanding. And as our population grows, we consume resources. Well, how do we do this in a way that doesn't um, affect the environment in a hugely negative way or in a way that is not sustainable? We'll look at what sustainability is at the end of this lecture, right? So how do we allow for the continued growth of populations? How do we help alleviate poverty in these areas, but do this in a way that isn't a detriment to the environment? And along the lines is hunger, right? We have a growing population. How do we feed this population without uh, a destroying habitat and resources, without polluting water and air, etc.? Right? How do we do this? Now, these are all topics that get discussed or are a part of this field of environmental science. Along the lines, I kind of just mentioned it, loss of biodiversity and conservation. How do we maintain biodiversity, maintain conservation of organisms or habitats in the face of this growing population or a population that is becoming more affluent, right? Typically is consuming more resources. How do we do this in a way that is sustainable? And really, what we're going to be talking about in this course or focusing on in this course is pollution, right? These technological advancements, as we have advanced, as our society has advanced, um, we pollute, right? We pollute in way by our energy production, by how we travel, how we farm. etc. The byproducts of these activities are pollutants, right? Sometimes, and then how do we address that, right? How do we um, do we want to pollute like that, right? Is that just the cost that we're willing to bear, or do we want to protect environments? Do we want clean water, clean air, etc., right? This is things that we discuss in this field and look at. Along the same lines, right? Climate change tied into pollution, because what is the driver of climate change right now is the emissions of carbon dioxide, right? A pollutant from these various activities. And just like I talked about, energy, how we get energy traditionally through um, coal and oil, natural gas, etc., right? The byproducts of that are different pollutants that can affect human health and other things. So all of these are wrapped up in this field of environmental science, and it's really those last three that we're going to be focusing on in this course, although we'll touch on some of the others. Now, I want to take a minute and talk about conservation and environmentalism in North America, right? So, a little bit of the history of it and where we get our ideas and some differing ideas on why we should protect the environment, really the natural environment, right? And perhaps kind of the first general or broad ideas behind conservation began in the late 19th and early 20th centuries. And it's this idea of utilitarian conservation. So this was developed from the writings of George Perkins Marsh and kind of put into practice by Teddy Roosevelt, who's my favorite president, and Gifford Pinchot, who was I believe his conservation officer, I think was his term. I'm not entirely sure. But they put some of this into practice, right? And the idea behind this utilitarian conservation is that resources or natural resources should be used for the greatest good, for the greatest number, for the longest time, right? So essentially, we should conserve natural resources or protect them so we can benefit from them, right? So we should protect water so we could have for our benefit, right? And our benefit in terms of clean drinking water or recreation or to be able to fish out of them, etc. Right? So the focus is on the benefit that we gain from having a clean, healthy environment and natural resources, right? What are the use that we can get from them? Now, this is contrary to another movement that was kind of developed around this same time, which is the biocentric preservation movement or ideas or concept. Right? And this was popularized by a couple different people, John Muir, Aldo Leopold, and Henry David Thoreau. Right? And this is not so much based on utility in terms of what we could gain from the environment or the benefit that we get, but it's more on aesthetic or spiritual or religious basis, right? And essentially, these ideas say that nature deserves to exist for its own sake, right? So there is inherent value in nature or the environment and should be protected because of that inherent value, no matter if it gives us any utility or any benefit at all, right? So it's a different viewpoint of why we should protect nature. And I want to bring these things up because in your career, if you go into environmental science or any sort of biology field, you may run across, especially in environmental science, you may run across people questioning why we should protect whatever resource, right? Why we should protect clean water, why we should care about climate change, why we should care about clean air. And you should have an idea, at least your own idea, of why we should, right? And it may be this utilitarian viewpoint. That's a lot of times I think that is the easier viewpoint, right? And it may be what you believe. That we should protect this for our own benefit, right? Just for that we could breathe clean air, and it's because we know air pollution leads to human health problems and earlier death, as we're going to see in this course, right? So we should worry about air pollution because of that, because it affects us, right? We should worry about clean water because we want to be able to utilize that water. And that's a very real, very good reason for why we should want to conserve the environment and resources. Um, but it may not always be the case, right? And there may be some times where, people will question why or do we want to save a particular species if it has no real benefit to us? And that's going to be a question that everyone should answer or should have to answer, right? If you are in that field, you may think, hey, why should we really preserve this? And perhaps you may agree more with that biocentric preservation, that that organism has some inherent value, that it should just be protected. And then there's also arguments that could be made that having protecting species, there are actual benefits that we gain from it as well. Um, so there's something called just existence value. So a lot of people, even though they're never going to see these organisms or interact with them, they gain some sort of appreciation for knowing that they just exist. Uh, Regardless, uh, two different viewpoints about why we should protect or conserve the environment, right? And I just want you guys to be aware of. Now, um, another kind of similar movement developed in the 1960s, which we refer to as environmentalism. And this really sprang from the publication of Silent Spring by Rachel Carson, right? And it's famous for documenting the effects of DDT. I'm sure you've probably heard of it or aware of it in some way. But really, with environmentalism, when it began in the 60s, it was really concerned with the threat of pollution and toxic chemicals to human and other species, really what we're going to be talking about in this course. Right, and from that, it has expanded now to include population growth, atomic weapons, fossil fuel extractions, recycling, etc. Again, all these things that we are going to be discussing in this course, right? Again, this isn't in opposition to these other ideas of conservation and preservation. It kind of takes aspects of both. It's something like I said, it started with this concern over pollution, and it's something to be aware of as we go forward. And it's really the topics that are included in environmentalism are really what we're going to be talking about in this course, right? Dealing with pollution and waste and how we address those in modern day. Now, that's the bulk of this lecture, right? I just wanted to talk a little bit about what environmental science was, a little history of why we may want to be concerned about environmental issues, right? Utilitarian or just inherent value. The last thing I want to touch on is what I'm referring to as the economics of environmental degradation, right? So why do we pollute, right? Why does pollution happen? Is there some sort of inherent economic bias that leads to pollution, etc.? And this is we're not going to get too in depth right here, right? There's probably a whole host of reasons for why pollution happens. But what I want to point out is this simple idea of a cost benefit analysis and how this oftentimes leads to poor choices in terms of the environment. Right. So if you're doing any sort of action, especially in your business, it's more formalized, right? But you tend to think of the pros and cons of something, right? So, and this could be anything, right? If you're thinking about buying a car or that particular car, you would list the pros and the cons, right? The costs and the benefits. Going to school, whether you should make some purchase, etc. Same thing is done in businesses and in terms of policy, etc. Right? Cost benefit analysis is this important tool. Sometimes it's formalized, where they give a monetary value to everything and look at that, or sometimes it's more informal, like what you might do with the pros and cons. But what is a factor of cost benefit analyses is that oftentimes the short term costs or benefits take priority over long term costs or benefits, right? As humans, we tend to give more value to things that are going to happen immediately than are going to happen over the long term, right? And we've actually formalized this in this cost benefit analysis in something called discounting, right? So the long-term costs or the long-term benefits are devalued compared to the short-term costs. Now, sometimes this makes a lot of sense, right? From from just a reasoning standpoint, right? And I'll give you an example. So if you are dying of thirst, you're wandering the desert and you're dying of thirst, you're going to put more value on getting a pint of water right now over getting 20 gallons of water 2 weeks from now, right? because your need is immediate. You need that water right now. So you're going to put way more value on that pint of water that you can get right now because you're probably not going to make it an additional 2 weeks, right? So there, it makes sense to discount that that those 20 gallons of water 2 weeks from now, right? They're not going to serve you any benefit because you'll be dead. But what happens is, because of that, and that's probably an inherent part of human behavior as well, right? Is this the short term? We put more value in the short term. But the problem with this is that environmental effects often occur in the long term, right? Both benefits and especially costs, right? So when we are polluting in water, or polluting in the air, or we are over harvesting fish or over taking any sort of over hunting, although it's regulated more now. When this is happening, we often don't see the costs of this until the long term, right? So we get these short term benefits where I don't got to pay to dispose of this waste. I can just dump this right out here. Or I don't have to worry about cleaning up these emissions. I can just let them go. To actually clean them and process them is a lot more money. And the cost of this, I'm not going to see for another 50 years, like 100 years, right? It's down the line. So you're not going to, you don't put as much value into those costs because those environmental costs are occurring over the long term. And as a result, a lot of times this has set up a situation where it allows us to pollute or to damage the environment in a way without necessarily worrying about those long-term costs, right? Because we don't see them. They're in the distance, right? And that's a real problem when it comes to aspects of the environment. And it's really with anything, right? It's in all fields, not just like energy production, but farming, right? Agriculture. Let's add more fertilizer. Let's add more pesticides. Even though a lot of that stuff is going to run off into the water, it's going to lead to huge dead zones and affect all these other aspects further away from where I am and at a further and in the future, right? You don't put as much stock in them because it's happening in the long term or in the distance, and we discount that, right? So it's a real problem, and it's something to be aware of when we start talking about some of these problems, right? Why is some of this stuff happening? Well, one of the reasons is we discount these long-term costs or benefits. Another problem with environmental degradation, the economics of it, is that for a long time, we haven't properly quantified ecosystem services. So what does this mean? Quantify just means giving a number to it, right? So there are services that our ecosystems provide that we can put a monetary value to, right? A good example would be wetlands, right? Our wetlands serve a number of functions, one of which, excuse me, is that they help reduce runoff and pollutants from entering our water, right? So there's a monetary value there that we could actually apply to if we had to run this water through different filters or water filtration. We can get away with having it go through this wetland, right, and reducing load. By the same terms, we could say, well, by having that, reducing that pollutants, as we're going to talk about water pollution, we're reducing inputs of nutrients. That is protecting shellfish, or that is protecting fish species that are important for recreational fishing. So now we can add a number to that again, right? By if those nutrients got in the water, and it's going to reduce populations by this much, and that's going to reduce the amount of fishing, we can start putting we can start putting numbers to it. And that's something that we are becoming better at now. So there's a whole new field of environmental economics that is dealing with this stuff, right? That is taking different services provided by the environment and putting a number to them to show the importance of them. So the last thing I want to end on is just talking about sustainability, right? Because I mentioned it early on. And it's one of the things that we're going to be focusing on in this course, right? How do we do things or go forward in the future in a more sustainable way. And what we're talking about is maintaining environmental resources or doing stuff in an ecological balance, right? So we need energy production. How do we get that energy production without the costs of the pollutants that are coming into our air, right? How do we get um, transportation, right? We need to get places. How do we do that again without polluting? So, or polluting to an extent that is detrimental, right? How do we feed people going forward, right? Without the some of the negative aspects of agriculture, right? So it's doing these things in a more sustainable way. So a way that allows this to persist at a level in perpetuity, right? So going forward, so we're not reducing these resources, we're not damaging the environment to an extent that we can no longer do it at some point in the future. So that is it. I will see you guys next week.